So our final speaker before lunch is Eric Ramat, CTO with Econolite. I think it's his second presentation at a PTV user group meeting here. It's been a few years since, but with our new sibling connection, it seemed like a great time since he's just down the road in Colorado Springs to have him come and talk a little bit about Centrax and directions of that and where we can go with integrating similar to ASC3, which we've done in the past when we weren't related. So Eric, welcome and Thank you.
Great. Thanks all. And to reintroduce myself, Eric Ramat, CTO at Econolite. Been with Econolite for about 23 years, so it's been quite a while with that. For those on the planning side that may not know Econolite, we're the leading provider of signal control equipment, pretty much everything but poles at the intersection is the way we say it. So what I wanted to talk about today was kind of digging a little bit into the weeds on the connected vehicle side, because there's a whole lot going on across the industry relative to connected vehicles. There's a bunch of forthcoming changes to the standards, and there's actually going to be a bunch of forthcoming changes to the recommended practice of how IOOs will be deploying intersections, will be managing intersections. There's a whole world coming down the pipeline based upon recent work. So I wanted to talk briefly through some of those and how they're going to impact signal control. And then I wanted to talk a little bit about the vSIM toolchains, in particular what we're doing on the signal controller, how we're going to tie it into the vSIM integrated platform, and really enable a connected vehicle in the loop. A lot of these progressive applications are going to need validation before we go to the street and we try these things out, and vSIM is really the perfect environment to be able to do that. So for those that have been around for a little while, for the last 20 years, we've been doing SPAT challenges in various connected vehicle deployments. They've gone on all over the country, and we really haven't seen a large scale of connected vehicle deployments. I think Georgia's probably the biggest with about 2,000 RSUs, but it's really kind of been a smattering across the industry. So we've had 2 decades of use, and then we saw the FCC start to pull back some of the spectrum, and part of the basis of that was we really weren't deploying enough. And so we started to really look at this and say, how do we really figure out what's going on? Why aren't we really creating mass adoption? Why aren't connected vehicles coming off the production floor, interfacing with the intersections? Why aren't they building the applications? What's kind of holding it up? And it boiled into 2 major areas. One, there's just a translation gap between the NTCIP world that we've developed for the last 25 years and then the SAE, the vehicle-centric perspective of the roadway. We were seeing among different controller vendors, even though the SPAT, the signal phase and timing message, is defined in the SAE standards, each vendor was interpreting it differently, and there really wasn't a clarity and a consistency. So the last thing a GM vehicle wants to do is have to worry, is this an Econolite or a Siemens controller as I'm driving through the intersection, and to have to discern those differences. So we in the vendor community had to come together and tighten it up. But we're seeing even more than that. There's just a language difference between the two. We in the traffic engineering side think about phases and overlaps. A vehicle has no concept of that. Everything needs to be geospatial. It needs to be boiled down to a lane ID, an allowable maneuver, and the set of constructs that you see within the SAE messaging. But we're also having to prepare the roadway for autonomous vehicles. And so in that case, just showing a red, yellow, green display in a vehicle is not enough. You need to be able to provide information to an autonomous vehicle for it to make a left turn. And so the level of rigor and quality and accuracy of the data sets really has to be brought up to a very high degree to be consistent with the SAE methods and within the automotive grade of data systems. As well, we were seeing a huge difference in the gaps of how traffic engineers think about the world. A lot of IOOs will deploy phase versus an overlap. We'll do some logic override in the cabinet. We'll drive these outputs this way. If we can make the signalization in the roadway match what the traffic engineer wants, that's fine. But where does that leave the data that we publish to the vehicle? If we've got an output override or we've got something else going on in the cabinet, the controller can't convey that information to the vehicle and we're stuck. As well, things like flashing operation. How the traffic controller isn't even aware of that. So how do you communicate that to a vehicle? And the thing we need to be mindful with all of this is that as we enable these connected vehicles, we're potentially changing standardized practices that have been in place for 50 years. We have about 10,000 fatalities a year at signalized intersections. And so we have to be mindful. That's the needle we're potentially moving in the good or in the bad based upon what we're doing there. So all of this kind of came to a head with a joint group we call the Connected Intersections set of committees. There's over 200 practitioners around the industry that came together, both on the automotive space, the IOO space, the standard space, and the vendor space. And we came together and we said, let's really fix this. It's been 20 years. We're about to lose the spectrum. We gotta clean up our act. We got to get together and we've got to do this. I was the chair of the vendor subcommittee, so I was representing all the traffic control vendors in this effort. And we really dug deep over the last 2 years to really try and fix as many of these problems as possible. I'll give one example that I'll kind of drill into here a little bit that'll give you the kind of the magnitude of change we're looking at. From the vehicle's perspective, they want to put software in cars that can drive in any state. From a traffic engineering perspective, you know that some states have a permissive rule of running yellow lights, and some have a restrictive rule of you got to get through the intersection before we turn red. So you've got a state variance in how that's applied. It's even worse than that, that the ITE formulation for yellow time is really based upon the time to get through the box of the intersection, whereas the attorneys behind the connected vehicles and the smart vehicle said, we want to actually get through the opposing crosswalk under yellow. So it's even more restrictive than you would imagine in terms of how the cars want to deal with that. So that when we were even talking about yellow clearance times and perception reaction times, the SAE world had a completely different worldview than we've had for many, many decades within ITE. So what we took in terms of the connected intersection working group is we said, let's focus on red light violation warning. That's just one of the many applications out there, but let's just really try, it's a real-time application, it's safety critical. Let's really try and run that to ground and fix what's broken with it. And so what came out of this was that we realized the yellow time is insufficient. The vehicle OEMs really wanted us to tell them when the light's going to turn yellow before it does. Anybody with any traffic engineering background in signals knows that we don't know when the signal is going to terminate. If we're sitting in green rest, the second a car pulls on the side street, we're going to go ahead and terminate green right away. So how do you tell a vehicle in advance of that? And really what they were asking for was, you know, kind of like the flashing warning beacons, an advanced light, red light, you know, an advanced warning end of green, I think they call it AWAG in the industry, for each of the signals. And so do IOOs really want to put 3 seconds of dead green time in and around that? How does that affect all the detection that's out there that was dialed into where the dilemma zone needs to be? So we were just at this impasse. And at the first one of these meetings, the vehicle guy said, look, if you can't give us this advanced warning into green time, we're just going to pack our bags. We're not going to put the sets in our vehicles. We're going to walk away, and we're just going to use self-sensing vehicles to figure this out. And this was really looking like it was a loss. So what we came up with was an assured green time as kind of the least disruptive approach. I think from a traffic engineering standpoint, we were backed into a corner. We said, we've got to do something. So we knew we had to leverage existent detection. Anything we did that changed the detection layouts, you know, we're talking about billions of dollars in infrastructure investment. We can't change that. We really want to make sure that the current clearance and gap timing doesn't change. A lot of these have PE stamps on the cabinets. Somebody certified those timings, and to modify those is a huge ordeal in some states. But what we're dealing with when we started to say, well, what does a connected vehicle need? Well, it really needs about 2 to 3 seconds of warning when it's reaching its dilemma zone. When it's getting within that range, then it needs to really know what's going to go on. So what we came up with was a kind of a middle ground solution, is that we will make the traffic controller aware of cars as they approach the intersection. When they reach their dilemma zone, we will then extend a call. And if we can't extend a call, then we're going to force the yellow termination decision and let them know at that point in time. So if we're coming up against a max out, then maybe we'll go ahead and terminate it and a little bit early and go. So we're fundamentally changing some of the controller logic when a connected vehicle is coming through the intersection. So this is going to have a profound impact, especially as we deploy this across, you know, 300,000 intersections. So the output of this work was the CT 4501 document. I don't know if you all have taken a look at this yet, but this is really the output of this effort. It's a good 300-page read. And really what it's trying to do is to put its arms around, how do we make intersections connected vehicle ready? What do we need to change in our practices? What do we need to change in our standards? What do we need to change in the way we do things so that a connected vehicle can get the data it needs and it can enable the in-vehicle applications? So there was a whole lot that came through on this, and as output of this, now the different SDOs are going to come in and update the standards, and that work is going on right now. So if you look at the SAE side and the connected vehicle messages, they're actually coming out with a new SPAT. We're changing SPAT as a result of this, and we're providing better data around what's going on at the signal to provide better information to the vehicles. We're also changing the SRM, SSM, the priority dialogues, and creating something that's a little bit more like NTCIP and removing some of the ambiguities. We're also putting out a whole lot of recommendations to IOOs, things like you can't do cabinet IO override anymore on the outputs. The traffic controller needs to be aware of that. We're going to add in a whole bunch of other details to try and remove these ambiguities. And so as well within TCIP 1202, we're right now going through a quick fix and doing a couple spot welds on a certain areas of 1202. And then next year, there's going to be an overhaul to TCIP 1202 to get consistent with this guidance. Examples being the traffic controller needs to know what colors we're flashing when we're in conflict flash. We need to be able to provide SPAT data even under conflict flash and startup conditions. Again, think about autonomous vehicles driving. They have to be able to trust this information. So the bar conformance is going to have to go through the roof on this. So there's a bunch of work being queued right now in NTCIP, and there's going to be a lot of changes coming down in that. So let me switch gears a little bit, kind of hopefully scaring you a little bit about the traffic control world is about to change and is in the process of changing. We on the Econolite side, we have about a third of the signals run our traffic control equipment. So we've been trying to get out ahead of this and start to implement some of these software changes in our traffic controller. We've got a tool that we call the virtual controller, which is basically a Windows or Linux-based standalone piece of software that runs the traffic controller. And so you can press the buttons and you can manipulate the traffic controller. So it allows people to kind of use software in the loop, simulation, emulation of the traffic controller. The nice thing about this is that it will still generate SPAT. It'll still support NTCIP interfaces. It'll do everything that a traffic controller does except control cabinet IO. And it allows the virtualization of those tools. If you've been a vSIM power user, you may be aware for the last decade, I think we've had the prior generation ASC3 as a vSIM plugin that you can select that traffic controller, and it utilizes the same source code of our prior generation traffic controller within that. And that allows you to then generate vSIM models, to use the COM interface, and to do all kinds of advanced stuff with a traffic controller that's running true NTCIP-based control within it. So what we're trying to do here is very similar to a concept that I presented 10 years ago at a PTV user group. About a decade ago, Purdue did a study and kind of showed the central system and all of the ATSPMs and everything we can do within a vSIM model. So you create the vSIM model, that becomes your roadway network. You have a virtualized traffic controller sitting within that then has NTCIP interfaces, and then it can communicate to your ATMS system. So you can basically simulate the whole world from ATMS and its capabilities to the traffic controller and its capabilities on down to, instead of the roadway, now we're using a vSIM model for that. So there's a great paper that Purdue put out about a decade ago on this. And what we're looking to do is to kind of take this and let's take this to the next step forward. And we want to take the connected vehicle 4501 guidances, put that in the new firmware, and expose the connected vehicle interfaces out from this modeling and from this system in the loop platform. So we're working with various research groups around the country right now trying to say, well, what CV apps are you trying to do? What are your data needs within this? And how do we build out this suite of software moving forward? So right now we've got, if you go to the vSIM side, all you can get is ASC3, but right now we're working on the next generation EOS firmware and the package around that. It's going to have the exact same operational code within the vSIM platform as we run operationally in the street. And that as we start to deploy these new connected vehicle technologies, we want to model them first in vSIM before we go put them in the street and turn them on and worry about the safety implications of changing things like the gap termination point within the controller. And as well, the data configuration files you're going to do in the simulation, you can then take to the street. So anytime somebody's going to do a connected vehicle deployment, we're going to try some of these new applications. We're going to do left turn assist. We're going to do red light running. We're going to do some of the leading pedestrian based upon PED vehicle conflicts. There's a bunch of other safety applications coming out. We're really encouraging folks to let's build a vSIM model of it first. Let's integrate the connected vehicle components within that vSIM model and then allow this to go outward. We're working with a few research groups, one of which is taking the vSIM COM interface and creating kind of a proxy basic safety message so that we can take vehicles out of the microscopic model and treat them as connected vehicles and then have them be represented within the data sets that go on within the CV standpoint. And we're also working on the NTCIP 1211 interfaces for priority request. I know that's been a big CV application, and making sure that that's mapped across into the new SAE messages that are being stood up that are more in alignment with the NTCIP 1211. So there's several research programs that we're engaged with. We're under NDA, so I can't talk about all the cool stuff they're doing, but my hope was to kind of get in front of you guys here today. And if anybody's looking at CV programs or getting involved in CV programs, there's a whole tool chain we've got behind the scenes here. and we're working within those research groups to say, hey, you can use the EOS controller. We can simulate some of these emergent technologies and changes. We can provide the SPAT data and all these other elements for you and help to kind of support your needs within that. So kind of putting all these pieces together, really what we see here is that the vSim is going to be your simulation of the real world. You're going to have a whole ecosystem of CV applications sitting on the other side. And the binding element right here is going to be this virtualized controller that sits in the middle and interacts with the vSim model, provides that, then also provides all the SPAT data and all the connected vehicle messaging outward. And as we're updating our firmware, we're roadmapped to do most of the CT 4501, I think about mid next year. We're going to have most of those new changes in there. We'll be updating, and then we will see the vSim plugin available. Right now, it's not available via PTV because it's kind of in dev, but if you guys do have an active project, reach out to me. We're happy to kind of engage with you, get you guys starting with some of the tool chains in advance of that, understand your needs, and make sure what we check in ultimately into vSim resonates and meets the needs of most of the researchers and most of the practitioners out there as you guys deploy CV systems. So I was